Okay, so this video is going to be for the first page of the Unit 12 review. So it'll be numbers 1 and 2. So we'll just work our way through the problems. So in the first one, we got this 40 by 10 sheet of paper, and it's been shaped into this cylinder. So first you get this kind of, oh, I guess that should be actually solid back there. So you get this curved thing, and then it completes into a cylinder. So if you think about it, this 40 right here turns into this circumference, the perimeter of that base up there. So the circumference is 40. And then the height is 10. So this is 10 and this is 10. So let's see, we got to find the volume. So volume of a cylinder, it's a shape that goes straight up and down and has the same bases. So that's going to be area of the base times the height of the cylinder. And the area of the base, since it's a circle, it's going to be pi r squared. And then the height is 10. So what we need is the radius. Well, we know that the circumference is 40. And we know that circumference is 2 pi r. So what we need to do is do 40 divided by 2 pi to get r. Now, if you do this on your calculator, a lot of people are getting the wrong answer for this. They're doing this, 40 divided by 2 pi. Well, if you take 40 and you divide it by roughly 6, you should not end up with 62. The problem is it's doing 40 divided by 2, which is 20, and then multiplying that by pi, because that's what order of operations has to do. So you're getting 20 times pi there instead of 40 divided by all of 2 pi. So you'd either have to do it like this, or you could do that shortcut, get the numerator over denominator, and do 40 on top, and then you don't have to worry about this being all underneath. So, okay, so the radius is about 6.3662. Okay. Oh, we just covered that up. Okay. So now I can plug that in over here. Pi 6.3662 squared times 10. And that ends up being, so let's see, pi times this answer squared times 10. 1273.2395. So remember the 5 rounds up, which makes the 39 a 40. So this is going to be about 1273.240. 1273.240. Okay, then we need the lateral area of the cylinder. So lateral area would be just the walls, right? Just this part, not the top or the bottom. Well, that part is this part right here, right? So that's going to be 10 times 40, 400. And then total area, oh, yeah, so let's put that there. Total area would really be if you pretended that there was a top and a bottom included now, like you taped on a top and a bottom. So it's going to be all the walls of the cylinder plus the area of the top and the bottom, which are the areas of the bases. Well, the lateral area we already know is 400. The area of the top, it's a circle, so it's pi r squared, and we know what r is. 6.3662 squared, plus another one of them, because the bottom is exactly the same as the top. So if you add all that together, I'll just tell you that comes out to about 654.648. Okay. So there's number 1. So let's look at 2. So 2, 2 sort of a ridiculous problem. You've got a quarter of a gigantic Swedish meatball. Radius 8 centimeters. Okay. And so the idea is that if you could see the whole meatball, it would look like this right there. And so what's happened is somebody sliced it this way and sliced it that way, and you're just left with this quarter meatball over here. Now, if you think about it, the question is, what's the area of the meatball, the remaining piece? And they say that the radius is 8 centimeters for this thing. So this, if I kept that sphere-looking thing here, that would be the center of the sphere. So if I draw it up to here, that would be 8 centimeters. If I draw it over to here, that would be 8 centimeters. Okay? And this surface that's going around like this is really a quarter of one sphere right there. Let me think, how can I describe this? There are 3 surfaces we have to consider here. There's the quarter of the surface of the sphere right here that's kind of doing this shape right there. And then separately, there's this face. And then besides that, there's also this one. So I'll number these pieces. Let's call this face right here face 1, this face down here is face 2, and then this face right here is 3. Okay, well, if you look at 1 and 2, let me clear this out for a second. If you look at 1 right here, that's actually half of a circle, right? You might think that it should be a quarter of a circle, but if you think about taking a sphere, if I slice it right in half, and you look at the shape you get, that shape right there is a circle. And then if you slice it again, then that circle is only half a circle. So it turns out that this one, in the same way, is only half a circle. And we know that the radius is 8. So when let me write this out. Total area of the quarter sphere is going to be the area of face 1 plus the area of face 2 plus the area of that curved part 3. So the area of 1, well, that's just half of a circle. So it's half pi 8 squared. And then the area of 2 is also half pi 8 squared, because it's also half a circle. And then the area of 3, this thing right here, is a quarter of the surface of a sphere. So it's 1/4 the area of a sphere. And the area of a sphere formula we learned on the last handout is 4 pi r squared. So that'd be 4 pi 8 squared. So then this is going to turn into, let's see, half of pi 8 squared would be 32 pi instead of 64 pi. We're cutting it in half. And then there's another 32 pi. And then this is going to be 1/4 of 4. So the 4th and the 4 cancel, and we're left with 64 pi. So then that's 64 pi here plus another 64 pi. That ends up being 128 pi centimeters squared. Okay, I hope